Hey friends, welcome to follow up. Let's have a look at problem 2483, minimum penalty for shop. So in this video, we are going to explain a solution based on prefix and suffix sum, or you can see we are using a format of dynamic programming. So here we are given the customer visit log of a shop, represented by a zero index string called customers. So consisting only of characters n and y. So for the ith character, if it's a y, it means that the customer come at ith hour. So if we have an n, which indicates that no customer comes at that hour. So here there's a definition for penalty. So if the shop closes at this hour, so notice the range of this G is between 0 and n, both end inclusive. In other words, G runs from 0 to n. There are n plus 1 indices, right? So the penalty is calculated as follows. So for every hour when the shop is open, while no customers come, the penalty increases by 1. And the second one is that for every hour when the shop is closed, and the customers come, the penalty increases by 1. So we want to find the earliest hour at which the shop must be closed to incur a minimum penalty. So here is a note. This is actually an important one. This is some convention. So if a shop closes at this hour, it means the shop is closed at the hour G, right? So here we have 3 examples. These examples are very easy to digest, so we're not going to digest them here. So the constraints is the following. First, the length can be as long as 10 to the power 5, right? So the customers consist only of characters y and n. So notice that. So this 10 to the power 5. So basically, a typical computer can treat 10 to the power 7 computations. So for here we cannot think of n square time complexity algorithm. That's one of the implementations of this number. And the customers as a list consists only of characters y and n, right? So with that said, basically we can look at the idea. So here basically we want to translate the penalty definition into prefix sum and suffix sum. So basically we can assume the customers have a length n. So this is just for convenience. So also I changed the customers to a just for convenience of writing. So I'm going to define prefix I. So I is the hour on which we close the store. So this prefix I will be the number of n's before index I. So notice that here it's strictly before index I. So this is nothing but the penalty due to no customer before our I if we close store at our I, right? Because the previous one are open but there's no customers. So here I is starting from 0 and ending at n. In other words, n plus 1 choices. So suffix I will be the number of y's on and after index I, because the shop closes at ith hour. It means the ith hour is already closed. So this is the penalty due to have customer on or after hour I. So notice the index here. We are seeing on and after. In other words, including the current index I. So in the prefix one, it's before, strictly before. Then for each closing hour, we could compute the penalty. So the penalty basically is the sum of the corresponding number in the prefix list and suffix list. And then we just need to do the proper return, right? So here, if we see, we formulate it as a dp. So the update is very simple. The prefix I for the current index will be the previous one, and then we check if the current character we are examining is an n, right? And the suffix one will be suffix I plus 1. Then consider if the character is a y or not. So here is the example 1, right? You can easily see, right? The penalty will be 3, 2, 1, 2, 1. So here we have 2 ones, but we need to return the index corresponding to the first one, that is our 2. So this is the digest or idea. So now let's do the coding. So when it comes to coding, actually it's very straightforward for this problem. Let's do some preparation right here. So we can initialize this n. So then we have a prefix sum, and a suffix sum, right? So here we can do something like this: 0 times m plus 1. In other words, length m plus 1. And the suffix also doing the same thing. So we have m plus 1, right? So for the initialization, notice the pre as index 0 means that if we close the store at our 0, right? But there's no previous index, so this initialization will be 0, right? And for the last index, that is index n, in other words, if we close at the store at our n, so this in the suffix also corresponding to 0 because there's no more characters after index n. So actually index n is also out of bounds for the customer list A, right? And then we are going to set up the elements. Set up or update the elements in pre and suffix, right? So this is very standard. So it starts from index 1 and ending at index n. So we write m plus 1 here, right? So then let's directly copy this part. Prefix I will be here, and then let's update for suffix. So we are going to start from n minus 1, and then we're ending at index 0. So we write -1 here, and the step will be -1. And then we are going to copy this part, right? And then what we want to do, we do the return. So for the return, because the length of this customer list is at most 10 to the power 5, so the penalty is at most, so 10 to the power 5, right? So let's plus a 1 here. The index, so the result, I'm going to make it n or n plus 1 as you like, but let's use n. Then basically we are going to iterate for I in range, so m plus 1, right? And then we are going to compute the current penalty. It's going to be the prefix I plus the suffix I, right? So sorry. So if current penalty is less than the penalty, right, the previous one, so we're going to update the penalty to be the current penalty, and then the result will be updated to the current index. There is another situation, that is current penalty equals penalty. So in this case, we do not update the result, right? So that's basically about it for this logic. And then we can do the return. So we are going to return the result state. So this actually forms a solution format. So here we write with great details. So basically, you can just use you don't need to use on space for this problem, right? But here that's just for the purpose of explaining the logic, so with ease. So before we make further comments, let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here, one thing I want to mention is that it's important for this problem to pay attention to the index, right? So here I try, but I make a wrong index, especially here. So here we need to be clear. So in prefix I, the number of n's strictly before index I. So here in suffix is the number wise on and after index I. So once you can pay attention to this point, and then I guess writing a accepted solution will be straightforward. So with that said, basically that's about it for this video. Thank